Having a DHCP server on your network is extremely useful as it helps make it plug and play. In other words, you can connect a device to the network and chances are it can then access other devices. But in a small network, dedicating an entire computer to be just a DHCP server isn't efficient. And using a firewall, for instance, as your DHCP server isn't secure because it then makes it vulnerable to more software bugs. Now, one practical option for reducing compute resources is to run applications in containers. But how do you build your own Kea DHCP server image for Docker, for instance? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because this video is specifically about building your own Docker image, I'm going to assume that you already have Docker installed as well as the build plugin, or you at least know how to install these. If not, then I do have another video available that shows you how to set this up in a Debian virtual machine running on Proxmox VE, for instance. Now, in order to build your own Docker image, you'll need to create a container file. And you want to keep these separate for each of the actual images you want to build. So for that reason, I'm going to create a new parent folder called images. Then within there, a subfolder called Kea, because we're going to be setting up an image for the Kea DHCP server. Now, because this is the first time I'm setting this up, I'm going to use the -p parameter to make sure that that images parent folder gets created. Then what we'll do is to switch to the actual folder. And then I'm going to use nano to create a file called Docker file. Reason being is this is a name that the actual build software is actually going to be looking for. Then I'm going to copy and paste in the instructions to build this specific image. Now, you need to start with a base image. So we've got a from instruction, and I'm telling it about Debian. In other words, I want to use the latest version of the actual Debian image. Now, it's up to you. You can use other operating systems. I just prefer to use Debian. So here on Docker Hub, you can see this is the actual image that we're going to be pulling down. Now, one thing I'll point out is that this is an official Docker image. Now, I think that's something you want to be looking out for because we've no control over these base images and we've got to start with something. So this one's got an official stamp, so it gives me some element of security knowing that this is an official image that's been provided on the actual hub here. But again, it's entirely up to you. You can go through this and pick something completely different to start with if you'd prefer. What we then got is a series of run instructions, and these are what actually install the actual DHCP server software. Now, this particular Debian image that we've got, it's very, very light. It's hardly got anything. You won't even be able to run like a ping command from it. But that's great. That's exactly what we want. All we're interested in is setting up an image to use DHCP. So the less software on here, the better, really. So what we're going to do is to actually get this to start with the Debian software and then install the actual DHCP server software. And that's basically it. However, the actual software, the operating system doesn't know about this software, doesn't even know where to get it from. So what we've got to do is to actually tell it about that, which means in essence basically updating the repository database that we've got on here and telling it about where it can actually get this DHCP server from. So to do that, we've got one instruction here. It does an apt update, then an apt install to install these dependencies, because what we're going to do is to add in the repository we need, and we're going to do that using the curl command. And then what that's going to do is to actually download this script file. It's then going to execute it using bash. Now, I'm taking a bit of a security risk downloading a script file from the internet, but I trust it enough. It's provided by ISC. Now, if we go over to Cloudsmith repository, that's where they're providing it to. So they've set up an actual script file to make setting this up a whole lot easier, but you can go through the manual process, if you will, of setting up the actual repository, signing it, and all the actual process that has to go through. Or you can just do it this way of just running the actual script they've already provided. Now, one thing I'll point out is that this version we're pulling down is 2-4. If we go back to the actual website here, you can see 2-6 is available. It's had very few downloads, so it's definitely far too new to be using. Last time I tried 2-5, it was complaining that it wasn't production ready. It might be now, at the time you're viewing this, but I do know 2-4 works. It's still working for me, so I'm quite happy to just stick with that. And as I say, what that's just going to do is just set up the actual repository database for our computer here, so that when we then go through the next run instruction, we do an apt update, because we have to update it now. We've added in that repository information to the computer before we can then install the actual software. Now, I'm only particularly interested in IPv4, in which case all I'm doing is to get it to install the IPv4 version of the DHCP server. You can check the actual website to find out what other modules are available, what you want to use, entirely up to you. But for the sake of this video, we're just going to stick with IPv4. So essentially what that's going to do, among all of those instructions there, is to get our Debian software, then install the actual DHCP server. Now, when it comes to the actual container itself, we need to actually let Docker know that this is DHCP server we've got here. Well, it needs to listen on UDP port 67, because that's what a DHCP server uses. And that's basically it as far as setting up an actual image and getting our software ready. Because once this is all done, you'll then be able to run that actual image as a container, and it'll have your DHCP server software installed. The only trouble is the way containers are designed. The idea is you create a new instance, it does something, and then it spins down because it's finished. It's usually just intended as a kind of like a one-off job, basically. We want this running all of the time, so we can't actually even run the DHCP server as a service. We've actually got to get it to run that actual software in the foreground so that it's running all of the time. So that's where this command instruction comes in. We're pointing it to where the actual software is, and I've got the -c parameter to point it to the actual configuration file that we'll be using. The only trouble is, if we don't define this line here, which sets the user, the software will get run by the root account, which isn't good from a security practice. If the software has any vulnerabilities which would allow somebody to then execute a command, well, it's going to get run by whatever account's actually running the software. So you definitely don't want that to be run by the root account. So for that reason, I've got that line there to tell it that when it runs this command, and this only gets done during the actual spin up of an actual instance. It doesn't get done as part of the build process. This is the build process essentially up here, I would say. This is more the execution of the container itself. But we want to make sure that this is run using a non-root account to try and improve the security as best we can, so that even if there is a software vulnerability, at least the attack is limited within the container to whatever this user account can do. And that user account does get created as part of the install of the software anyway. So the account's already ready to go. So that gives us our configuration, or container file, I should say. So I'm going to save that. And then we're ready to actually build our image. Now the next thing to do is to actually build our image. And we're going to be using the Docker plugin to do that. So what I'm going to do is just copy and paste in a command. And what we're going to do is use Docker, then build, to actually build this image. I'm using -t as a parameter because I want to tag this as Kea_image, that's its name. Then we've got a colon and then 0.1 because I'm going to be using versioning, and it does make a lot of sense to use versioning. I'm not going to go into too much details about it, but it is very important to have versions. I mean, although users will typically want the latest version, for instance, you can run into problems where you create a newer version of software, and what then happens is people download that newer version, find it's not compatible with other things they're working with, in which case they'll want access to an older version. So what I tend to find is it's useful to create an actual image that's got a version number like here of 0.1, but then I'll create another version which is the latest version, and you can make both of those available to users. And then as you keep making changes and adjustments and you get newer and newer versions, we'll get 0.1, 0.2, 0.3 and so on. You'll always have a latest version, which is the latest version, but you'll have all of those older versions as well that users can always fall back on if necessary. In any case, it's entirely up to you, but it's just part of the versioning process when creating software. But finally, what we've got on the end here is a dot or period, which is basically just telling it where to find the actual container file, which is in the present working directory. So I'm just going to hit return. And then what it's going to do is to download the original actual Docker Debian image, I should say, from the Docker Hub. As you can see, it's going through the process now of downloading all of the software that goes with it, that we've told it to do within the actual instructions of that container file. Well, as you can see, the process has now actually finished, and it's actually created a new image for us, which is version 0.1. So now we can actually start to use this image to run containers. Well, now that we've got an actual image created for our DHCP server, we can actually use that to create a container. How you do that? Well, it really depends, but in my case, I prefer to use Docker Compose. So the first thing I need to do here is to switch to my home folder, because that's where I'm keeping the actual Compose file. So I'm going to use nano to edit that, and I've got it called docker-compose.yml. Now, because the file already exists, I don't have to put in version compatibility details, they're already there. I've also got a volume section defined, but I need to get Docker Compose to create a volume for the DHCP server. Reason being is that the DHCP server is going to lease IP addresses out, and it needs to keep track of them. Now, the problem with containers is they lose data if they get restarted, for instance, and that would be a real big problem. So let's say, for instance, it's actually got a local file where it's storing the actual IP leasing, which in our case it will, because it's using CSV files as the database. Then it leases out an IP address to a computer, it then gets restarted and completely forgets all about that. It's then spun back up again, and lo and behold, it leases out the same IP address to another computer. Well, now you've got a conflict on the network, and those two computers just can't function properly. So that's why we create this volume here. This is going to be used so that the data actually persists on the actual host itself. So we've already got a services section, so we don't need to create that. So I'm just going right to the end of the file here, and I'm going to copy and paste in the details for our Kea DHCP server. So normally, as you can see, I'd probably point it at the latest version, but we're still in the early testing phases. We've only just created this image. So for that reason, I'm pointing it to this 0.1 version that we created. I'm giving it the name of Kea, just to make it easier to visualize and identify on the command line, for example, when I'm using the tools. I'm telling it what port to use, which is UDP port 67. For the restart, I've got this set to unless stopped instead of always, because if you set it to always, well, the problem is if you stop the actual container, then Docker Compose will automatically spin it back up. That could be a problem for maintenance, for instance, if you want to make some changes. With this method, it still automatically restarts containers, but if you manually stop the actual container, then it doesn't. So I find that is a more preferable way to keep your containers running automatically, but give you that maintenance window if you need it. Now, when it comes to volumes, the way we're setting up Kea is it's going to use a local database file. It's basically just going to create CSV files, and they're going to get stored in /var/lib/Kea. So for that reason, we're mapping that over to this Kea-data volume that we've defined at the top of the file here. The DHCP server also has a config file, which from the container's perspective is in /etc/Kea, and it's called Kea-DHCP4.conf. We need that to actually survive a reset, for example. So for that reason, in the present working directory, we're going to set up a folder called Kea, and we're going to store the config file on the actual host itself. So that will actually get mapped out to any container that gets spun up, and that way the config, we can maintain it outside of the actual container itself, and it'll also survive, as I say, resets and restarts and so on. The problem we have when it comes to DHCP servers, though, is that, well, the virtualization when it comes to containerization actually gets in the way, and it causes a whole heap of problems, I've found. So normally when you're creating containers, what you can do is just don't define any networking and they end up on this default network. That's the way these containers work. There's a network in the background, if you will, network address translation and so on going on. So the host's kind of acting as a sort of like a proxy between the physical network and the containers that it runs, and that gets in the way of the DHCP server. So for that reason, this is the only container I'm setting up here where I have to define my own custom network. I have to basically give this actual container direct access to the live physical network. So for that reason, I've got a network section. What I'm going to do is I'm going to create my own network. I'm going to call it infra. I'm using IPv4, so I'm actually going to assign this actual container an IP address on the real physical network. In this case, 192.168.102.33. So that way, it'll still be able to function correctly. If I'll just leave it on the actual default network, as I say, it just causes all sorts of problems. So having told it what network to actually connect this container to, I then need to actually define the network. So I've got a network section. So there's my new infra networks that we've referenced up here. Now, I do have choices to get this on the real network. So you do that by setting the driver. Now, you can use Mac VLAN, for example, which as far as I'm aware, you can use it for Docker, but you can't use it for Podman. But I prefer this over the alternative, which would have been the host method. Now, the reason for that is that, well, what I've found is that if I use the host method, I have to then run the Kea DHCP server using the root account. And I don't like the security risks there because of the potential for software vulnerabilities. And then somebody, if exploited that, they would then potentially be able to install whatever software they like on the actual container and just cause all sorts of havoc. By running it with a non-root account, it's limited to some extent. It doesn't really do anything in terms of a potential breakout, but it seems to be my preferred method to use this Mac VLAN approach, where I can still run Kea with a non-root account, but still put it on the actual main physical network. So having defined the driver, I then also have to define these driver optional entries. So this is basically just to define the networking. So on my computer, the host computer, it has an interface which is called ENS18. You'll have to find out whatever your actual host's interface is called. You can find that by running IP space A, for example, and it'll give you details about that. But the reason I'm doing that to some extent is because within the actual configuration of Kea itself, I have to tell it what actual interface to use. So that's why I've got this ETH0. I'll be able to reference this ETH0 within the config file. It doesn't matter what host I ever run this container on, it'll always be called ETH0 that way. Then this interface only depends on the actual host. It shouldn't really make any difference when it comes to the way I've got this set up. I'm running the actual Docker platform within a virtual machine anyway, to be fair. So it'll always have this interface, at least on these types of servers I run, of ENS 1.8. So yeah, those are just things to bear in mind because of the configuration of the actual key. You have to reference the actual interface by its name for some reason. So now that we've defined that portion, we then have to set up the IPAM for this network. Now, in my case, there's only this actual container is going to be on it. I still have to actually define the subnet here, and I still need to define the default gateway, but the actual IP address that's actually assigned to this has actually been defined within the container settings itself up here. But by setting this all up this way, we're putting the container really right at the front of the host. Essentially, we're bypassing the network virtualization and we're getting around problems that would otherwise occur because of the way this virtualization works in containers. And so far in my travels, it seems somewhat unique to the DHCP server. I mean, if we go up to Node Exporter, that runs in host mode, I've noticed, but that's just running locally within the actual computer itself. It's only there to actually gather information about the actual host, whereas here we're talking about a container that needs access to other computers on the rest of the actual network out there. So yeah, it's a kind of an odd situation, and it's a bit of a dilemma in the sense that I've still got to run the actual container itself with a root account, which Docker does by default. If you just do a default installation of Docker, all your containers are run with a root account, but that's essential. It's the only way you can punch through the network virtualization, unfortunately, and there is no way around it. When it comes to this driver option, as far as I'm aware, Podman doesn't give you that choice, which is unfortunate. It does have a host mode option, but it doesn't have this Mac VLAN option, which means if you were to run something like this on Podman, as far as I can see, you'd basically have to run the actual container as root, and you'd have to actually run the actual software, the DHCP server, as root, which, yeah, that seems like a bit of a pain, to be honest, given the whole point of what we're trying to achieve with Podman versus, say, Docker. So these are things to bear in mind. So at the moment, I'm only running this on Docker because of the fact that I can at least get some security benefit of still being able to run the actual DHCP server software with a non-root account. Anyway, we've now got our Docker Compose file created. Now, the server here will need a configuration file, but we don't want to keep that within the container because any changes would get lost. In which case, we've got the Docker Compose file configured to map that config file out to a file we'll have on the host. Now, I do like to keep these config files separate for each container. So the first thing I'm going to do is to create a new folder, and I'm just going to call it Kea. Then within there, I'm going to get nano to create a file called Kea-DHCP4.conf. In other words, that's the actual name of the config file for the IPv4 server module. Within there, I'm going to copy and paste a sample config. Now, I don't want to go into too much depth about this configuration. Reason being is that the video is more about actually setting up Kea within an actual container. But I do have another video which shows you how to actually set up Kea, and it does cover this in a bit more detail. And although it shows you how to set it up within a virtual machine, for instance, the config file is basically the same. Now, what we've got right at the top is an interfaces config section, because we've actually got to tell the DHCP server what interface or interfaces to listen on. Now, when we set up our Docker Compose file, I actually told it to actually assign ETH0 as the interface for containers. So that's why I'm referencing that interface there to listen on. Then what we've got is aligned for the DHCP socket type, which is basically to say what types of traffic to listen for. Now, by default, this is set to raw, but the actual recommendation is to use UDP. The reason being is that your typical firewall can't filter out raw traffic, but it can filter out direct UDP traffic. So that's why they suggest setting this to UDP. Now, For somebody like me, that's not really a problem because the actual DHCP server would typically be in a dedicated network for infrastructure servers. All those computers would have static IP addresses, so therefore they're not sending out this raw traffic of broadcast requests to get an IP address through DHCP. If you've got a small network and your DHCP server and your clients are in the same network, well, then you've got a problem. You're very much reliant on that raw traffic. The only catch is when I've set this up as a container, the container doesn't actually get that broadcast traffic anyway. It does make it to the actual host, but it's not actually passed on to the container. Even though I'm using Mac VLAN to actually give this container a direct connection essentially to the main network, it's still not getting those broadcast requests. So for me, I may as well set it to UDP anyway, because it's not going to get that raw traffic. So I'm solving like the security challenge anyway as part of the process, but it's something you need to bear in mind, and I will show you how you can resolve that issue if you do have computers on the same network. Anyway, the next section we've got is for setting up a lease database. Here can be connected to a dedicated server if you like, but we can also use CSV files, and what we're doing is to actually map this folder out to a volume so that this sort of information does persist. Then we've got some timers for the leasing. Then we've got our global options set here, so typically your DNS servers and the domain name that you're using, although you can define those on a per subnet basis if you like. And then we start to define our subnets here. So I've got one subnet, so we define that inside a notation, the actual IP address range that we can lease out, and then that subnet's got its own dedicated gateway, and you can put in reservations if you like, as I've showed here. So you can set up multiple subnets, you can have reservations within there and so on. But that's about as far as I want to cover it. It gives you a basic configuration here of two separate subnets, because the format for this is very crucial. I mean, if you notice here, for instance, I've got a comma at the end of that bracket where that bracket ends, but because this is the last section, I don't have a comma. If I'd had multiple reservations within here, I would have to put a comma after every bracket here until we get to the last reservation. So it's a bit complicated in terms of its format, and I'm only using Nano. There are better editors you can use, but because it's a video, I'm just going to try and keep things as simple as possible, if you will, in case you don't necessarily have the software for that type of editor. But anyway, now that we've got our config file defined, I'm now going to save that. Now, because the DHCP server won't be receiving any DHCP broadcast traffic, it means I'm going to have to set up what's known as a DHCP relay agent on every network that I've got, including the network where the DHCP server is. Basically, what a relay agent does is it listens for the broadcasts. It then turns it into an actual unicast and it just forwards that directly to the server. Now, how you set these up depends on what you're using. So, for instance, I've got OpenSense, which is a firewall. It's acting as the actual default gateway for all of my networks. So I'm using that as a DHCP4 relay. Now, it can act as a DHCP server or a relay agent. It can't do both. And it can't be selective on each individual interface, for instance. It's all or nothing. It either is a DHCP server for all of your networks, or it's a relay agent for all of your networks. So something to bear in mind. But in our case, we're only interested in a relay agent. So you come down to Services, DHCP v4, then click on Relay. And then we've got a relatively simple configuration here. We enable it. We then select the interfaces to listen on. And then we put in the list of actual DHCP servers. Now, when this lab was originally set up, I had a virtual machine, which was servicing every network. Now it's a case of transitioning across to an actual container. But I can't set this up so that certain interfaces are using one DHCP server other interfaces are using another. It's not that sophisticated. So I've got to pick out all the interfaces to listen on and all of the actual servers to send the traffic to. I've then got to be very selective in terms of the configuration of the DHCP servers. So the virtual machine I've got, which is on 192.168.100.11, for instance, will be servicing subnets for these 4 networks, whereas my container, 192.168.102.33, will be serving only IP addresses on this test network that I've got. Yes, the requests will be going to both servers, but essentially anything for, say, like the test network would get ignored by my main virtual machine because it's got no configuration for that network. But yeah, it is pretty simple to set up. It's just things you've got to bear in mind, that if you're doing, say, like a transition, for example, here, like from one server to another, you've got to be very careful about your configuration within the actual DHCP server to avoid the potential of conflict, for instance. So it's pretty simple to set up, especially on OpenSense here. And it is a bit unusual in terms of the DHCP server is actually going to be in the same network where the clients are, but this is how I can get around this problem of the actual container not actually receiving those DHCP broadcast requests. Well, the next thing to do is to actually try and spin up our container and see if we can get our DHCP server working. So because I'm using Docker Compose, I need to use the Docker Compose command to start this container. I want it to bring up containers, run them in the background. So that's what the -d parameter's for, run in the background. Now, if I don't specify the actual container, it'll just go through that list and bring up every container that isn't already running. But here I'm going to be a bit more specific. I'm going to say just focus on this one container that we've created, this new one called Kea. So I'm just going to hit return. Now, that is interesting. First time I've seen that where it's actually complaining that the version is obsolete. It's the first I've seen that, so that's new to me anyway, so that's something I'm going to look at. But it looks like it's at least started our container. So then what I'm going to do is have a look. So Docker PS you can use to have a look at the state of containers that are running, for instance, but there's a -n option and then 1, which basically then only focuses on the last container. So in this case, it's saying, oh, it's only been up for less than a second. Right, so I'll hedge my bets and say there's something wrong within the configuration, and for that reason it can't actually bring this container up. So what I can do is actually have a look at the log files here. So Docker container logs, and then just point it to the actual container. Subnet without ID 192.168.254, not within the subnet. Yeah, so it's a configuration. Basically, like I suspect that there's a fault within the config file, so we need to have a look at that. So nano here, then Kea DHCP4.conf. So somewhere within here, not surprisingly, I'll have been doing copying and pasting, and there'll be something I haven't done properly. I probably won't have edited something. I mean, it mentioned 192.168 something or 255.4, I recall. So this is the subnet 192.168.102.0/24. The start and end are within that subnet. The gateway, that's within the subnet, so it's not there. This is the 250 network. So again, the third octet is 250, so that's fine. The default gateway is 250, so that's fine. There it is, it's the reservation. So that's what you get for copying and pasting. So this IP address is in 192.168.254, and we've got a subnet 192.168.250. It can't allocate an IP address from outside of the subnet, so I need to fix that. And we'll try and bring that back up again. Well, so first things first, I'll stop the actual container. So because at the moment it's just constantly trying to restart the container, and it won't work until we actually get it set up properly. So I'll just tell it to stop that specific container. So Docker compose stop Kea. Then I'll try again and see what we get. Okay. And I'll have a look and see what its state is. So it's been up for 7 seconds, 10 seconds. Yeah, so it looks as though that is now working. So yeah, just a simple config error. Typically where there's going to be a problem, it'll have either been somewhere within the compose file. Maybe I might have made a mistake there, or config file. And with a config file like this, it's very easy to make mistakes, especially when you're doing like copying and pasting, for instance, or if you've created some sort of like syntax error. But that's looking a lot better. So have a look at the logs on this one. So basically it'll be receiving probably requests. I wouldn't be surprised if it's actually getting requests from the actual firewall for the subnet. So I wouldn't be surprised to be seeing errors like that showing up, but that's about as far as we've got here, where it's saying that it's actually started. So that's actually a good sign. At least the DHCP server now looks to be up and running. Now at this stage, the container's up and running, and it looks as though the actual DHCP server is actually working, but is it actually leasing IP addressing? So what I've done is to spin up another computer in the background, and sure enough, it's obtained an IP address. Now, in my case, I've actually got 2 DHCP servers. It should be configured correctly, but I want to know which server has actually handed this IP address out, because when I look at the client, it's just saying it got it from the actual DHCP relay agent. So I'm still a bit in the dark as to who leased the IP address. So this is a good opportunity to actually show you how you can actually check the Kea server to find out what's actually being leased out. So there are different ways you can do it. You can go and have a look in the actual volume and check the file that way, but it seems a bit overly complicated to actually find out what the volume is in the first place. So instead what we're going to do is open up an exec session. We're going to literally connect directly into the container and find out that way. So docker exec -it, want an interactive terminal session. We want to connect into our Kea container. We want to use the bash shell to do this. So that's showing me that I'm connected in as that _Kea user, which makes sense because that's what we were using to actually run the software. Then what I'm going to do is have a look in the folder /var/lib/Kea, because the way this was set up is that it's just basically using CSV files. It doesn't connect into a database server. It's just creating its own CSV file. So we'll have a look in that folder, and sure enough, there's our CSV file. Now, it does actually loop through files. I mean, once that file gets full, it then actually creates another file and stores the older entries in that, and then starts using this anew from fresh, basically, and it just keeps looping through. So you can actually have multiple files, but that one will always be the latest file to check. But if you've got other ones, you might have to check in there. The other thing you'll find, you can have multiple entries as well for a single IP address that's been leased. So these are other things you need to bear in mind. But anyway, what we want to do is actually have a look at the contents of that file. So I'm just going to use cat. So we'll show you, sure enough, you can see there's multiple entries here just for this one computer called test server. And yeah, this is the one that's leased out the IP address, because I knew the computer had this IP address 192.168.102.100. But as I say, you do get multiple lines. Eventually it actually clears out multiple entries. It's part of this like a process that it goes through to actually purge out older entries. But usually that's all you're looking for, is just a single IP address plus the name of the host. You don't necessarily always get the name of the computer. Some of them don't necessarily hand it out. But then there's the actual MAC address as well that will go with that. So that's good. I can see that this computer is the actual one that did that. So now that I've checked that, I'll just exit out. So that is basically how you can actually check what IP addresses have been leased. Now most end users will be wanting to use the latest version of an image. And what we've done is to create a version 0.1. We've tested it. It looks like it works. So what we want to do now is to finish things off and create our actual latest version. So what I'm going to do is to actually switch to the folder where our actual Docker file is. So for me, it's in images/Kea. Then what we're going to do is to use Docker build to create another image, but this will be the latest version. So Docker build -t for tag, and then the name is still Kea_image. Because I'm not specifying a version, then this will actually become the latest version. We're already in the actual folder, so the current working directory is where our Docker file is. So I can use dot as the target, hit return, and then it'll build that new image. Now, it won't take long because we haven't made any changes, and it does actually do caching. So I now need to go back to the home folder because I need to update the Docker compose file and tell it to actually use the latest version. So nano docker-compose.yml, because that's what I've called this one. I'll go to the end and then go back up a bit. We'll change this from 0.1 to latest. Then we'll save that. We're then going to stop this container. So Docker compose stop, then Kea, because that's the container we specifically want to stop. And then we'll spin it back up again. So Docker compose up, -d to run it in the background, and then Kea because we only want to focus on that one container. So we'll just wait for it to bring that container up. And then technically nothing's really changed. It's exactly the same image, it's just got a different name. But although it should work, I'm still going to check. I want to use docker ps and then -l as the parameter. It's another way to filter out the list of containers that are up and running, or at least trying to run, because -l means just show me the last one that was started. So I can keep running that command a few times. Yeah, I mean, not surprisingly, it was working before, so it should still work again. So yeah, this one seems to be pretty stable. But because we've been making quite a few changes, I'm going to run the Docker system prune and then force it to tidy things up, basically just to clear the system out, because we've been making quite a few changes. And it's just deleted unused objects, basically. Managed to recover a small amount of memory, but it's quite useful to run that command every now and again just to clean things up. But now we've got the latest version, and our DHCP server is now up and running. Now over time, you're going to need to update the configuration of the DHCP server. Maybe you need to update a subnet, change a reservation, add a new reservation, and so on. In any case, you need to update the actual configuration file. Now, for us, this is a container, and the actual config file has been stored on the host. So I need to edit this Kea-DHCP4.conf file in my Kea folder. I'm just going to use nano for that. So let's say I want to change the IP address in this leasing from 8 to 18. So save that change. Now the only trouble with this server is you either need to configure it to be able to reload a configuration, or typically restart the service if you're running it in a virtual machine. In this case, we're actually running it within a container, so we may as well just restart the actual container. So what we're going to do is then use Docker compose restart, because that's what I'm using here, Docker compose, and I'm going to tell it to restart this Kea container. So it's basically similar to restarting the actual service for the actual DHCP server. So there you go. So just double check, make sure it didn't have any problems, because we made a change to the configuration, and if you've made a syntax error or something, then it could go wrong, break. So you still want to double check that the actual container is still running and it's not got any problems. So it seems to be working perfectly fine then. So that's how you make a configuration changes. In a small network, reducing your compute requirements will probably be important, because they should help reduce the power load, leading to less energy consumption and reduced costs. And As we've shown, you can run infrastructure services like a DHCP server and containers to help you do that. Building your own images is relatively straightforward once you understand the process, and while a DHCP server container does have some quirks, you can still create one. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.